In this video, I'm going to go over how to find and use the greatest common factor, in other words, the GCF. So I'm just going to write that down so that we know what GCF stands for. It is our greatest common factor. So let's start with an example. Let's say that we are given the expression 12x plus 15. Now, what we're going to do is we're going to break this up into each of the factor pairs that these two numbers or terms can be split up into. So 12x, we could split that up into 1 times 12 times x, 2 times 6 times x, 3 times 4 times x. So those are all the different ways to split up 12x. And then if we look at 15, we can do 1 and 15, 3 and 5. And so what we want to do is we want to look at these two lists and we want to find the greatest thing that they have in common. So they both have a 1, but that's not the greatest one because they also both have a 3. So I'm going to go ahead and circle that. Now only 12 has an x, so they do not both have one. If they did, that would kind of change how we do this. So I'm going to rewrite down here 12x plus 15. And I'm going to actually split 12x and 15 into its two factors using the greatest common factor. So right here, I've split it up into its two pieces. If we were to divide 12x by 3, we would have left over 4x. And if I were to divide out 15 by 3, I would have 5 left over. Now, this might look weird when I go to write my final answer, but we're going to actually go backwards using the distributive property to show why this ends up working. Now, because 3 is being multiplied by both 4x and 5, we can rewrite this as 3 times the quantity of 4x plus 5. Okay, now I'm going to go backwards using the distributive property to see if we can see where that comes from. So let's say that I started with this expression. I had 3 times 4x plus 5. I know that if I have an expression like this, my job is to take this number on the outside and multiply it by both terms inside my parentheses. Now, I usually skip writing this step, but let's actually write it down. If I were to do 3 times 4x plus 3 times 5, you guys should recognize that step. It looks just like this middle one. Okay, and then when I simplify it, I'm going to end up with 12x plus 15. So all we're really doing is going backwards in the distributive property. We don't usually see this step, but it kind of helps us understand how we get down here to our 3 times the quantity of 4x plus 5. So we're going to try another one where we actually have another term. So let's do 16x squared minus 12x. So there's a couple things that are different about this one right off the bat. Number one, we've got a squared value. Number two, we've got a minus sign. So it's going to change how this looks a little bit, but not too much. So again, I'm going to split my two numbers up into their factor pairs. 16, I'm going to have 1 times 16 times x times x. I'm going to have 2 times 8 times x, and 4 times 4 times x. And then 12, and you'll notice I'm going to be ignoring the negative sign for right now. We will come back to it, but for right now I'm going to ignore it. I have 1 times 12 times x, and I have 2 times 6 times x, and 3 times 4 times x. Now, if I look at these two lists, I have more than just a number in common. I now also have a letter. So my greatest common factor would actually be 4x because they both have that in common. So if I go to rewrite this similar to how I did up above, I've got 16x squared minus 12x. And I'm going to again split these up into their two factor pairs. I'm pulling out 4x from both of them. Now, it is positive 4x, so I'm going to put that plus sign there. You'll notice I still haven't used my negative. It's going to come in there. So 16x squared, and I want to divide that by 4x. So if I divide 16x squared by 4x, what I should have left over is 4x. And you should see that up here. Okay, what I have left over if I pull out that 4x is 4 and x. Now, I have negative 12x divided by 4x. I have to account for that negative, so negative 12x divided by 4x is actually going to be negative 3. And that's where that negative sign is going to come in. So now I need to rewrite this just like I rewrote this one. My GCF is going to go on the outside. So I've got 4x on the outside. And on the inside, I'm going to take my expression. And in this case, it actually has that negative in there. So I'm going to have 4x minus 3. And you can use a distributive property to see if you end up with the same expression. So I'll do that over to the side. If we were to start with 4x times the quantity of 4x minus 3, if I distribute that back out, I should end up with 16x squared minus 12x. So 4x times 4x would get me 16x squared, and 4x times negative 3 would get me negative 12x. So it was correct.